Prove using sine formula tan of a minus b by 2 divided by tan of a plus b by 2 is equal to a minus b divided by a plus b. We start with the right hand side and apply sine formula and substitute a by k sine a and b by k sine b, taking the k common and then cancelling it out from numerator and denominator. We are left with sine a minus sine b divided by sine a plus sine b. In the numerator we can apply the sine difference formula and replace sine a minus sine b by 2 cos a plus b by 2 sine a minus b by 2, and in the denominator we can apply sine sum formula and replace it by 2 sine a plus b by 2 cos a minus b by 2, cancelling out the 2 common between the numerator and denominator, and then replacing sine by cos of a minus b by 2 by tan a minus b by 2, and replacing cos by sine of a plus b by 2 by tan of a plus b by 2 in the denominator. We get the left hand side. Prove using sine formula b cos b plus c cos c is equal to a cos b minus c. We start with the left hand side and from sine formula we can replace b by k sine b and c by k sine c, taking the k common and observing that both the terms are in the format of product of sine and cos of the same angle. We can apply sine 2 theta formula, giving us k by 2 sine 2b plus sine 2c. We can apply here sine of sum formula on sine 2b plus sine 2c, where a is equal to 2b and b is equal to 2c, cancelling out the 2 common in the numerator and denominator, and also within the sine and cos term we are left with k sine of b plus c cos b minus c. Within a triangle we know that a plus b plus c is equal to pi, which implies that b plus c is equal to pi minus a. So sine of b plus c will become sine of pi minus a, and we know that sine of pi minus a can be simplified to sine of a. So we'll replace sine b plus c by sine of a. Again from the sine formula, k sine a can be replaced with a, giving us the result a cos b minus c. Prove using sine formula a sine b minus c by 2 is equal to b minus c cos a by 2. We start with the left hand side and from sine formula replace a by k sine a. Further we apply sine 2 theta formula on sine a and replace it by 2 sine a by 2 cos a by 2. Now within a triangle we know that a plus b plus c is equal to pi. So from there we get that sine a by 2 is equal to cos of b plus c by 2. Now let's focus on the last three terms, which is 2 cos b plus c by 2 sine b minus c by 2, and we can replace it using sine difference formula, that is sine b minus sine c. Again from the sine formula we can replace k sine b and k sine c by b and c respectively, giving us b minus c cos of a by 2. Prove that a cos a plus b cos b plus c cos c is equal to 2a sin b sin c using sine formula. Observing on the right hand side, we find that only one side, that is a, is used and the angle b and c are used. So we start with the left hand side and convert b and c in form of a, that is replace b by a sin b by sin a and c by a sin c by sin a. Doing the substitution, we observe that a is common in all the three terms, and in second and third term sin a is common in the denominator. We also observe that the terms are sin b cos b and sin c cos c. So to apply a formula of sin 2 theta, we need to multiply the second and third term by 2 and simultaneously divide it by 2 also. After applying sin 2 theta, this gets simplified to a cos of a plus sin 2b plus sin 2c by 2 sin a. For sin 2b plus sin 2c, we can apply sin some angle formula and replace it by 2 sin b plus c cos b minus c. Now in a triangle, a plus b plus c is equal to pi implies that sin b plus c can be replaced by sin of a. We can now cancel out 2 sin a from the numerator and denominator, and we are left with a cos b minus c. Now again looking at the triangle, a plus b plus c equal to pi, we can replace cos a by minus cos b plus c. Now we'll rearrange the term and then apply cos minus cos formula to get 2a sin b sin c. If a by cos a is equal to b by cos b, prove that the triangle is isosceles. From the sine formula, we know that a is equal to k sin a and b equal to k sin b. We'll prove this using two different methods. In first method, we'll prove that the angles are equal, and the second method will prove that the sides are equal. Now, we are given a by cos a equal to b by cos b. So, we can substitute a and b from the sine formula, then cancel out the k on both the sides and replace sine by cos by tan, giving us tan A equal to tan B. As the two tan values are equal, it implies that the angle A is equal to B. This means that the triangle is an isosceles triangle. Second method, here will prove that the sides are equal. So we again start with A by cos A equal to B by cos B. Now we can do the cross multiplication to get A cos B is equal to B cos A. We'll take the square on both the sides. Now we'll replace cos by sine, and then from the sine formula we can replace sine b by b by k and sine a by k. Doing the simplification and cancelling out the common terms, we get a square is equal to b square. Now as a and b are sides, they will always be positive, which implies a is equal to b. That is, the triangle is an isosceles triangle.